So I think the point I'm trying to make is that as you sit here as students, that future of really continuing to design cars that are affordable, that are certainly desirable and affordable, cars that have as small an environmental footprint on the planet as a whole, cars that can really start having an impact in terms of even the kind of value they provide to you. I think those are all very, very fascinating. There's a whole set of opportunities there that small component represents. So sort of that was the purpose of showing the education slide there. But tacit in that is also research and how upstream research gets conducted as a means of therefore creating new value in the context of education. So that might be more applicable to master's students or PhD students, but clearly also very much applicable to undergrads as you go through your educational process. This is sort of a little blow up. I won't spend too much time on this. Credit goes to the United States Department of Energy to have sort of certainly envisioned this. Many of us see this. This is sort of a vertical slice of this complex system, if you will. What you see up in the sky are all kinds of hydrocarbons and CFCs that ultimately go there and circle back in various forms. But again, the point here I'm trying to make is that the automobile is a small, tiny speck in this bigger context. But this is an intensely connected, complex system. It's also, for the most part, wirelessly connected. It has nothing to do with electronics, though. It has to do with gaseous elements that are floating up, just happening, that mix with lower Earth atmosphere systems. But it's a complex system. It's a complex connected system, and it's a complex connected system that all of us live in and are part of. And so every little component now comes together to have a direct impact on this complex system. And so if you sort of pose the inverse problem here, the inverse problem would be you want clean air. And how do you now how do you solve the inverse problem of defining and redesigning the components that then drive towards that clean air that then has a societal impact? This is sort of I'd say, a horizontal view. And the credit for this goes to NASA for recompositing these pictures. These are pictures that you might have seen. It's sort of a very popular picture. But the reason why I kind of show this is it gives a real good sort of horizontal view of the complexity. And clearly there are dark regions that indicate that perhaps there's no human habitation or there isn't much of it, and there's growth there. There's chance there for growth or opportunity for growth. And then there are brightly lit areas that show urban mass populations, if you will. But the point is that, again, the automobile is a small component in this large complex system. There's a huge amount of coming together from the standpoint of R&D, student undergraduate work, and certainly advanced collaborations at the academic consortium collaboration level between industry and academia to be able to solve challenging inverse problems. So the inverse problem, looking at it from the top down for this sort of horizontal slice, is if I'm an individual and I want affordable personal mobility, how do I now offer this in the context of what you see here? Or maybe the not too distant future where you have these 19 cities with 20 million people or more. So in this very complex urban setting, do I really want to own a car? Or do I want to be able to lease a car when I want it? Or do I want to ride in someone else's car because I know that I can go to the same destination and ride back in someone else's car because I know that person is also coming back home? But then the IT systems that do so much for us every day can somehow connect us in a manner in which it's really painless for both the driver, who gets a direct cost benefit because they are taking someone else with them, and for me, the individual, because I don't want to own a car. So it might sort of sound a little blasphemous coming from a car manufacturer that I don't want to necessarily go make more cars, but I think that's the reality that we face today, and that's really the commitment that we have, that as a vehicle manufacturer has been around for 108, 109 years, our story is not about making more cars. Our story is about really saying how can cars be an active participant in a world where you have a number of choices. Maybe you want to walk, maybe you want to ride a bicycle, maybe you want to take a train, maybe you want to take a shared transport system. And it's part of that complex equation that we think we're a valid player and a valid component. So I think that, again, allows for different business models, different technology interplays, and therefore really a bright future in terms of what we can go ahead and do collectively. So this is just a quick schematic. It looks too artificial and too synthetic. It's clearly an artist's rendition, but everyone's connected, doing their own thing. The world is nice and happy. The father's driving along. But I mean, this is the Cocoon idealistic view of the world. No potholes, no traffic congestion, life is good. So you can, obviously people are going to be continuing to build cars with either that allure or towards that kind of an image. So there are aspects of this that are real today, others that might be real tomorrow. But really, this was just a little reminder for us, that part of the daily job that most car makers will always be investing in and doing. So cars are going to get better, cars are going to get quieter. We don't have to do much in terms of sort of coming together to make that kind of a change. There's already a lot of investment, but this is just a sort of a mnemonic reminder of that. This piece is sort of a interesting statistic, and it also is a reminder to us, and I'll sort of share this with you. The source for this, the raw data came from Wards, and then I sort of put this together when we were putting a publication together. But the point that's worth noting is obviously the slope at which the increase in registrations is progressing. So this is, again, the 1 billion number. That this data is a little old, 2005. Today's data shows sort of numbers that are higher, so you're at 1.2, 1.3 billion. Continued extrapolation. The little dip in the 1945, pre-45 era shows the impact of wars, and so that really caused that dip there. Data wasn't available. Most of the manufacturers of automobiles went on to doing other things, primarily to support the wars, making aircraft or making tanks and things of that nature. But the R&D investments had actually already started. So if you see this schematic here, this is actually really interesting in terms of what is not on this, but of course bearing in mind these curves that are on it. And so what is not on this? What was happening at the same time that's not explicitly shown here? The computer was getting put together. There was a huge big computer, ENIAC, and various versions of that, and there was exactly one of those available. You could argue that if you considered Zuse's machine in Germany, there were maybe 2 or 3 computers in that 1940 time frame. And so computing machines were coming together. If you fast forward to today, you have a sophisticated computer, maybe 1 or 2 in our purses and pockets right here. I mean, there's more computing power than there was all collectively put together for many, many decades out there. And so that growth had already happened, had begun to happen then, and it's here with us. If you take the telephone in that time period, most of us, and you can't remember, but most of us didn't really, no one could buy a phone. So the next generation or the generation after us obviously didn't experience that piece, but some of us do remember the days when you couldn't buy a phone. The phone came with a subscription. You applied for a phone, you waited for 5 years, and if you were nice and everyone was nice, someone came home and they polished a black instrument and they connected it and they went away. And then once in 6 months they came with a little pink cloth and they wiped it, and then everyone went and wanted to go use the phone because it smelled good, and that was it. You couldn't buy a phone. There was no notion of being able to buy a phone. So fast forward to today, who doesn't have a phone? And so there's a phone in our purse or pocket. So again, these things have just transitioned. So this is all really a backdrop. I'm using this slide as a backdrop, and those are things happening right here in parallel to the automobile itself. So that is the opportunity that we have today. And along with the change in communication and computing, there's been a dramatic change in material science, in analytical tools, in being able to manufacture and process products, in the ability to transform what's in people's mind about design to actual product and form and bring that up to scale. So I think there's a phenomenal amount of coming together of tools, of hardware, of software, of the wetware, the brain itself being able to map and do things. So I think we're at a really interesting transition point now as we proceed to the second billion. And so this is sort of just an artist's schematic again. So, this is not analytical sciences here that created this chart, but really the point is that the automobile of the not too distant future is going to be a very effective probe for the planet. And so as you get to the second billion, there's going to be ways to map automobiles and what they probe and what they offer as data to valuable information for you to make decisions with respect to personal mobility or in general being able to deal with the urban megacities, if you will. So what is a specific concrete example? What do you do? I mean, why bother listening to this? And what's your role? So I would say as you look into the future, there's sort of a couple of considerations to bear in mind. One is to start looking at automobiles as platforms for the implementation of your ideas, your dreams, in manners in which you can scale the realizations of those dreams to billions, really. So I think that's a big opportunity. It used to be that planning and design and engineering and business decisions were made off in some remote place, and manufacturing took place in some other area, and then out came the product, and you went and bought the product. I think those days are essentially gone. You would have to now design a product based on local knowledge, local wherewithal, and local relevance. Obviously, you want to get the efficiencies of scale that comes from being able to commonize parts and components, and that businesses will do anyway. So you'll have a lot of sharing of parts and sharing of components, but there's a very good opportunity for us to add value in a very local sense. This gives us room for opportunity for R&D, for interesting work to happen at the undergraduate and graduate level. I think there's a whole set of those kinds of technology opportunities. So one specific example of the networked effect of automobiles is worth mentioning. There's sort of two things. One is, as the second billion comes together, unlike the first billion, the second billion will be network ready. So it'll be as if finally you've got laptops that have a network connection. Today you have a billion laptops on wheels that have no network connection. Some of us can sort of relate to it because we were actually used to carrying around laptops that didn't have a network connection. And then we inserted a card and it got some kind of a Wi-Fi connection. And then it evolved into laptops that have a built-in network connection. But the next generation sitting here really can't relate to things that are not networked. And so what you're going to find really is networked automobiles, network-ready automobiles, and then how you use that network-ready state to define the value on top of that platform of connected automobiles is really where the future is. So if you look at it in that context, you can look at actions that an individual car takes. So whether your wiper blades are going on, and that's a piece of information, it's a piece of data that you want to now offer up to someone else who aggregates that data. So if you have 10 cars that are going in front of you, maybe a kilometer in front of you, all with their wiper blades on, and that's a statement that's being made. It can be really useful to the lorry driver who's coming, a kilometer behind, because it means that the road ahead is either foggy or there's rain or there's some reason to go to exercise added caution. The infrastructure to do that is essentially almost already there. To make it affordable, to make it easily usable, that's obviously the set of challenges ahead of us. But really, to be able to collect and aggregate information is an old story, already becoming a well used experience in the context of cell phones. And so, how do you now take this and make this ready for the road, if you will? So I think that's an example of how the coming of the second billion means two things. One is, of course, the linear growth, if you will, or maybe I'd say a linear growth in the number of automobiles, going from 1 billion to 2 billion, but maybe it's a little non-linear in terms of getting there faster. But the network effect is going to be exponential. So in other words, the second billion are going to be interacting in so many different possible ways that the net effect that we have in front of us is going to be exponential, and really by definition, the human mind often is not able to predict exponential effects or network effects or even complex system effects. So what you're really going to be seeing is a complex system effect in the context of the next billion. What I mean by that is, as automobiles become sources of data, as data gets aggregated and presented as information, there's so many different ways to slice that and present it to the driver. So there's a huge set of opportunities ahead of us. That's sort of at the network and aggregated level. At the level of the individual automobile itself, there's real questions about utilization of the asset. And I think we spoke about this in a little chat session before this meeting, so it might be a little repetitious to some of us, but really imagine a pure business side of this discussion here. It says that the car is probably the second most expensive device or asset that you will pay for.